We good?
Yes, sir.
Okay. Now, again, if this was a situation where they stuck together, I would probably say something had a velocity before, another one had a velocity afterwards, they stick together. What is the final velocity? Well, you would need that mass. How would you come up with that final mass? Yeah, you would add the two masses up before the collision. All right? A 5-kilogram ball is 2 meters in the air. And let's call it 5.0 and 2.0. 5.0 kilograms and 2.0 kilograms. I mean 2.0 meters. What is the ball's potential energy? Potential. Or intentional. We haven't done any intentional energy problems yet, but so what do y'all get?
98.
98?
Yes, sir.
What?
Joules.
98 joules. All right. Assuming that that ball starts at rest, what is its kinetic energy and velocity upon hitting the ground? And velocity upon hitting the ground. Anyone have the kinetic energy yet? Very good. Why is it 98 joules?
Energy before equals energy after, and there's no energy after.
Yeah, there is no potential energy at the ground, so at the ground its kinetic energy would be equal to what its initial potential energy was, and we just solved that to be 98 joules. So how do we determine the velocity then?
Plug it in kinetic energy equation.
Yeah, we can plug it into the energy equation. Kinetic energy equals 1/2 mv squared. So kinetic energy is what?
98.
98 joules. 1/2, what's its mass?
5 kilograms.
5 kilograms. So essentially we would have, that would be 196 divided by 5. You'd multiply that by 2, which would be 196, and then divide it by 5. Or you could take 98 and divide it by 2.5. What do you get? 39.2. That would be meters squared per second squared equals V squared. So V would equal to
6.26.
6.26 meters per second. Is that good with everyone?
Yes, sir.
Fired up, Sam? Aye.
Oh,
I want to make sure you repeat yourself, but Chris was kind of mumbling. I didn't really hear what he said about the potential energy and the kinetic energy. Can you say that again? I just didn't catch all of it.
What did you say?
So basically, the law of conservation of energy.
Okay, yeah, all right, I remember now. The potential energy at the top was the same as the kinetic energy at the bottom. Because law of conservation of energy says that the total energy before is equal to the total energy after. So at the bottom, when it hits the ground, it has no potential energy. Now again, when that ball hits the ground and has stopped, where has the energy gone? Well, yeah, it could be absorbed in vibration, right? Sound, heat, those things are where the energy goes. Did y'all know it was Friday?
Absolutely.
Yes. I couldn't tell that y'all would be glad it was Friday. A lot of y'all are just...
You're so zoned into food right now.
That hurts.
Gotta go home sometime.
You've been home most of this week, ain't you? What days were you out? Okay. Henri, you fired up? Groovy.
Why do you call them Henri?
French.
It's French.
Henri? There's a real name, Henry.
That is Henri.
Henri.
He's so appreciative that I call him that.
Have you seen his little brother? Looks just like him.
Chandler?
No, Chandler was. No, not Chandler. Not the one that looked like him.
He's got one that's like twins.
Well, I'm going to go ahead and tell you.
Same
It didn't take me long at all to say, hey, I bet Chandler and Henri are related. I think y'all look alike. I mean, no offense. But he's not French. He's American. Don't tell him that. At least he is. Okay, I'm almost getting off topic.
Almost.
What now?
Got a Ravens fan.
I'm sorry.
What?
Anything else? Any other types of problems y'all want to see? We really don't have time for everything. Yeah. We've got a good bit of time, but we don't have time for quite
We
everything.
don't need to learn something new.
No, we're not. Well, if y'all don't give me any other types of problems, we're going to learn something new.
Oh, somebody, let's see. Hold on a second. Yeah, we need to work on mechanical advantage problems.
Mechanical advantage? Okay.
And I did mechanical advantage also.
Yes.
We're going to use a pulley. To lift a pulley system, I should say, not just a pulley, but a pulley system. A pulley system to lift a 500 Newton object 3.5 meters. To do this, we will use a 150 Newton mat or Newton object. How far are we going to move the other object? 3.5 meters. So let's move it.
6 meters.
Yeah, 6.0 meters.